Okay, so today I want to do support vector classifier for number recognition. So if you have some handwritten image, so suppose, no, just a minute. So this is a regular paint if you're using Windows. I think Mac also has something like this, right? Yeah. I want it to be kind of like a square. And this is a square. Okay, so let me crop it. And let me just draw, say I want 8. I want a bit thicker. Let me put 8. Okay. Let me draw it again just to. Okay. So let me resize this to 8 by 8 pixels. And here's my nice looking image 8. Can I zoom in further? Oh, this is the most I can zoom. Okay. And then I'm going to save this in some folder I can easily access. Let's see. I'll just go to C, users, Dan. All right, so I'm just going to save this as 8.png. Okay. All right, so let me try to load that in Jupyter. So Python 3. Now the Python function that can load pictures is called pillow. It's called PIL. From PIL, this is Python image library, and it's just called pillow. From PIL, import image. So that's what we're going to do, and then we will also need NumPy. So import NumPy as NP. Okay. And then, let's see, where did I save it? Where did I save it? So it's here. Okay, so A goes to image.open, quotation. In Windows, you need this R. It's a bit annoying. For Mac, you don't need. And then 8.png. Okay. I'm going to load that. And then we will make A as a NumPy array so that it's easier for us to access. Let's see what's in A. Okay, we have a bunch of things. What is the shape? A.shape. Oh, this is not a function. Okay, it's 8 by 8 by 3. Where is the 3 coming from? It's coming from the fact that it's an RGB. So you have 3 channels, red, green, and blue. But you know, like any one of the channels will do because our thing is grayscale, so we just need one of them. So let's do this. We'll say B is going to be A. The first rows and columns, those we just take. This column means we take everything. Okay. But then we'll take the R channel, red channel, the 0 one. Okay. If we look at what's in B, here's what we have. Now, can you see letter 8 here? See, 255 means it's white. 0 means it's black, so it's like the values are smaller is somewhere here and then somewhere here, so that's really 8. If you want to actually convince yourself, you can plot this by using matplotlib. So let's do that. From matplotlib, import pyplot as plt. We can do plt.imshow b. Look, it's the same 8 that I drew, right? Okay. All right. So now what do we do? Now we are going to get the data set again inside the sklearn, so we don't have to do much. Let's see how. Oh, that's not the one. This one. Okay. All right. Okay. So let's do from sklearn dot datasets. So this is the same place where we downloaded the iris dataset last time. Oh, I should make this bigger. So from sklearn dot datasets, we're now going to do import load digits. Okay, and then we are going to say digits equals load digits. And last time we had as frame. Yes.
So sorry, but from before when you were changing it from the 883 to 880, I guess if you left it as 3, would the image come out having red in it? Since you said like those correspond to color.
Oh, no. The imshow just treats it has this color scheme. It's just using a color scheme to show this. If you want the grayscale picture to appear, then there's there's something that, yeah, you can do CMap. Yeah, so if you want grayscale, this is what you can do. Comma CMap color map is equal to plt.cm.gray underscore r. Yeah, that's the grayscale. Then you get this. Oh, it should be the opposite. Okay, so let's do this. 255 minus b. Yeah, then this is what you get, right? Yeah, it's the same thing. Yeah, it's imshow just takes values and yeah, it just maps it with a color map, and the default color map is red, yellow, blue. That's why it was showing something else. Okay. All right, so let me execute this. No, what is this? Oh, why did I do that? Okay. All right, so it's going to download the data sets, and now digits has the data set. Okay. So let's see. What is the type of digits? It's something called a bunch file. And just like before, you can print the description. Print digits DSSCR description. And it says optical recognition of handwritten digits data set. It was originally 32 by 32, and they reduced it. In the homework, I was asking you to do the MNIST one, modified NIST data set, where it's 28 by 28. I couldn't use it here because it's just too large. Right? Okay. So just to convince you that these are really digits, let's also do plt.imshow. The digits.images, and the images are indeed the NumPy arrays that you can show. So if I pick this one, what does this one look like? It has to be numbers from 0 to 1, so yeah. And what about, just pick any random number. What's the size? I think this is like, description should have something. 1797, that's how many images it has. So just pick a number between 0 and 1,000. Give me a number.
97.
Huh?
97.
97, okay. Let's see what's in there. What does this one look like? 4, right? Okay. So what we want to do is we want to make a machine, the actual values, if you want to know the actual values, let's put it here. So this is what it is, okay? And I see that the values here are between 0 to 16. The highest value is 16. So later on, if I want to use the trained machine learning to be applied to the handwritten digit that I have to squash the numbers between 0 to 255. So I really need to divide this by 16. Then it's going to give you values between 0 and 16. So when this is fed in to the support vector classifier, it's going to give me 8, hopefully. All right. Okay, so let's actually do the classifier. We will need to train the test split, right? So we're going to do from sklearn dot modal selection import train test split, and then we're going to say x train comma x test comma y train, no, oh yeah, y train comma y test equals to train test split, and then we're going to do digits dot images, and then this digits dot images is our data, right? But then what we have is not in the same correct dimensions. We have to flatten it. So what I'm trying to say is that these images are two-dimensional arrays, right? But our support vector classification can't handle two-dimensional arrays. So I want to make this into a single array. But then there are 1797 data points, and those are, so you have 1797 two-dimensional arrays, so digits.images itself is a three-dimensional array. Does that make sense? Okay, it's a three-dimensional array, and I want to reshape this so that it's a two-dimensional array, and the way you do it is you do, what's the size here? 1797. So it should be 1797, comma 1. Okay, so, oh, no, it's not that one. Okay. Number of, yeah, so that should be it. Okay, yeah. The second one is really 8 times 8, so the second number is 64, but let's just put it as -1. We'll figure it out automatically. Okay, so that's our digits images flattened to become single arrays, and then we are going to feed in the y underscore train. Oh no, digits.target, sorry, digits.target. Digits.target is the labels. So if you do digits.target of 97, it will tell you it's 4. Let me just do this first. If you do digits.target of 97, then it says 4, which corresponds to this, right? So these are the labels, okay? So what I did was I took the images and divided into train and test, and digits and target are divided into train and test, and I'm just assigning them as x and y values. We should also define test size equals to 0.2 as before, And another thing is, if you have a large data set, sometimes it takes a lot of time shuffling it. So let's just say shuffle equals to false. Okay, and I'm going to execute this. Now that's executed. And then now we are going to import from sklearn .svm import support vector classifier. Okay, and we are now going to do that as a clf equals to support vector classifier is equal to support vector classifier of, and this is where you treat the gamma. So I talked about the gamma, right? Gamma, I'm going to put 0.001, which is going to be kind of soft. And then I'm going to fit it with the train x, x train, comma y train. Okay? Oh, that was fast, okay? And then this is actually going to, I had to do it from here in my office because I ran out of time. So as you can see, the image 97 is 4. Let's see if our trained support vector machine does indeed get that correctly. So here is svc.predict, and we're going to feed in the data, or digits.images, and we're going to take that 97th one, but then we have to reshape this because it's a single image, and therefore to reshape it, and also we trained the support vector machine using flat array, so it has to be an array where the inside array is the length 64 information of this thing, right? So let's put in reshape -1 comma 64, and then if I do that, I get array 4, which means that indeed this is 4. Okay, so so image dot open, and then r user stand, then it's 8.png, and let me save this in number 8. 8 is this, and I want this to be numpy array, so let me convert this to numpy array after it's opened. Okay, let's see what's in 8. All right. Oh, and we decide to only take the first part, the red channel, right? So it'll be 0 or 0, and then we will reshape this to 8 by 8. Okay, so I had some trouble because it couldn't read my handwriting, and so what I did was I looked at some examples of 8 inside the test training sets, and this is the example of an 8, and you can see that because this was first drawn in a high-res 30 by 32 and it downsampled to 8 by 8, it's really hard to read that this is 8, but you can see that your number has to be somewhat close to the middle, narrower, and you have to just imagine what kind of 8 it would be. So what I did was I went back, and then I drew this 8 and downsampled it to 8 by 8, and then I had to reload it. So let me show you how I reloaded. I reloaded by executing this again. Then I remembered that the big difference between my drawing and the data set is the values here are 0. The 0 is drawn as white in ImShow. So, but the values here are darker, which means it's a higher value. So my values go between 0 to 255, which is not good because it has to be 0 to 16. So I'm doing two things. First, I'm subtracting from 255 so that this dark becomes white. So when the value is 0, it will change to 255. If the value is 255, 255 minus 255 will be 0. So I changed that. I also took only the red channel because I need the grayscale. And then I reshaped it as 8 by 8. And I also divided by 16 so that the values are between 0 to 16. But see, the problem is I didn't draw mine hard enough so that the values are not now somewhere between 0 to 10. But it's okay. So here's what I have. And then I'm going to define a new thing, read as the same thing I had here, divided by 16. But I add this round thingy so that the values are integers. I don't think it matters, but just to be sure, because all the training sets are integer arrays. So I did that. And then if I draw this thing that I defined, now it looks like this. It's actually worse than before. My previous 8 seemed to be more beautiful, but well, this is closer to the training set. So if I execute the predict, now it shows me correctly that this is 8. So it read my handwriting. Okay. All right. So now sklearn function from sklearn.metrics confusion matrix display. Sorry, import. And then I'm going to make it display, confusion matrix display from predictions. And I'm going to compare the Y test, which is the actual value, actual labels of the data. And I want to make the support vector classifier to actually make the predictions using the X test. So let's see what that does. Okay, so this is what happened. Now you see that some of these are misclassified, but many of these are correctly done. Okay, and then furthermore, if you want to know the predictions, you can do so from sklearn metrics import classification report, and then we can print classification report, and then y test and y dot svc dot predict x test. Okay, and then now it shows that we have the precision. Some of them are close to 1. Some are, the worst is 0.84. The recall, the worst is 81 here. And F1 score is overall pretty good. It looks like the worst one is when you're trying to read 3. It doesn't have a good performance. But the other ones, well, I guess 8, yeah. So I see another problem here. I was suffering so much trying to make it read 8, but 8 was one of its weak points. So it looks like this support vector machine is somewhat having trouble reading 3 and 8. And seeing that 3 and 8 are kind of, you know, they look somewhat alike, right? And I think that's why it was giving us this problem.